Good morning or good afternoon, and today we're back to continue talking about trigonometry, or just remember that it's trig for short. So if you think back to yesterday, we talked about trigonometry and we talked about trig ratios, and we had this little table with all of our values and all of our charts. Now, for this first problem, it just says find sine of R, cosine of R, and tangent of R. So we're revolving around angle R. There's no need to solve. All that it wants is the fractions. So if you remember from the other day, we had our formulas. So the easy way to remember them is SOHCAHTOA. So is sine, stood for opposite over hypotenuse. C is cosine, stands for adjacent over hypotenuse. And T is tangent, which stands for opposite over adjacent. So if I'm going to find sine of R, it's all revolving around angle R. First, I need to figure out which is the opposite side, which is the adjacent side, and which is the hypotenuse. So across from R, that would be my opposite side. That's going to be 45. My hypotenuse would be across from the box, which is 53, my longest side, which means that 28 is the adjacent side. So if I'm going to do sine as opposite over hypotenuse, so sine of R would be O over H, which is going to be 45 over 53. And if you're not sure if that reduces or not, remember that we have that trick in the calculator. You can do 45 divided by 53, enter, and then press math, enter, enter. And if you do that, you're going to go from 0.8490 back to this exact same fraction. So that would just be our answer. And now I'm going to move on to cosine. So cosine is adjacent over hypotenuse. So cosine of R would be adjacent, 28 over 53. And for our last one, for tangent, so T stood for tangent. Tangent is opposite over adjacent. So tangent of R would be opposite, which is 45 over 53. And none of those reduce, so we're just going to leave our answers just like that. Now, on this one, there was no solving. They told you find sine of R, cosine of R, tangent of R. There was no x anywhere in here. There's nothing for us to solve. I don't need to go to the trig chart. I don't need to deal with any of that. But when I have a problem that looks more like this, well, this is when I get into the whole solving part of if x is up high, we multiply. And remember, whenever x was down low, we switched and we divided. So I'm going to go ahead and start out this problem by circling the acute angle that they gave me. So they told me that angle A is 43 degrees. And now I'm going to look at what else I have. Well, x is across from 43, so that would make it opposite. There's nothing on the hypotenuse side, so I'm not going to end up using the hypotenuse. So I can go ahead and cross it out. And then that means that 9 is adjacent, my last side. So if there's nothing on the hypotenuse side, I'm not going to use the hypotenuse at all. Asking yourself, would this be sine, cosine, or tangent? Which one uses the legs? Which one uses opposite and adjacent? And if you said tangent, you're correct. The trick for remembering tangent was TOA. So I'm going to say tangent of, and if we think back to our formulas, it was tangent of theta. Well, theta is my angle. This time it's 43. Remember that you don't have to memorize those formulas. You should be able to find them, whether they're in your notes or on the board or somewhere. You should have those formulas. They'll always be provided to you. So tangent of 43 would be opposite x over adjacent 9. Now, remember, whenever x is up high, we're going to multiply, but first I need to know what is tangent of 43. So this is where my trig chart comes into place. So tangent of 43. So tangent of 43 is 0.9325. So I'm going to go back to that problem. I'm going to replace tangent of 43 with 0.9325, I think it was. Yeah. So tangent of 43 is 0.9325, and now I'm going to multiply. So 0.9325 times 9, or 9 times 0.9325, and x would be about 8.39. And that's it. Now, if it said to round to the nearest tenth, 8.39 would round up to 8.4. But remember, if it doesn't say, then I can go ahead and go out 2 decimal places. So remember that whenever x is up high, we end up multiplying the numbers. So let's take a look at this other one. I have x on the hypotenuse, so I can go ahead and already label that side as the hypotenuse. The acute angle that they told me was 51. And then I have the opposite side. And then there's nothing on that third side, which means I'm only going to use opposite and hypotenuse. So asking yourself, which one uses opposite and hypotenuse? Well, that would be sine, or so, if you want to remember it that way. I like the little SOHCAHTOA phrase. So sine of 51 equals, opposite would be 14 over x. Well, I need to go to my chart and figure out what is sine of 15. So we can go ahead and do that. If you go look at your chart and you find sine of 15, anytime you have trig problems, you want to make sure that you have your chart handy. And if you can see it, sine of 51 should be 0.7771. Remember that we don't round from the chart. We keep that decimal 4 places out. So 0.7771. Now, when x is up high, we multiplied. So on the last one, we just multiplied those two numbers. But now I need to divide. And the easiest way to do it is to swap them out. So swap out x and your decimal. So x would equal 14 over 0.7771. And that's your clue with what to divide by. So now you're going to do 14 divided by 0.7771 and type that into the calculator. And you get a fairly long decimal. You get 18.015694. Remember, we just want 2 decimal places. So that 5 would round the 1 up to a 2. So I'm going to say that x is approximately 18.02. Now, if we go back to do just a quick check on this problem, my leg was 14 and my hypotenuse is 18.02. That makes logical sense. My hypotenuse should be bigger than the leg. But let's say that I put 8, or let's say for whatever weird reason we got like 0.5. Well, there's no way that your hypotenuse could be smaller than the leg, which is a clue that you did something wrong. So if I take a look at this next one, there should be a box in here. Sometimes every now and then things just get cut off. So let's go ahead and draw that box in there. Let's make this a right triangle. This one's a little bit different because x is inside the triangle. So x is inside of the triangle. Okay, so I know 2 sides of the triangle. I know that the leg's 5, and I know that the hypotenuse is 14. But thinking about this, it's not a Pythagorean theorem problem. I'm not trying to find the leg. I'm not trying to find this part right here. It's not a special right triangle. I don't know what these angles are, but I have x on the inside. Well, this is where backwards trig can help us out. We know that triangles on the inside add up to 180, but we don't have enough information. If I knew that this was 40, then I could add and subtract from 180, but I don't know that angle. The only thing that I know is 2 sides. And if I know 2 sides and I'm trying to figure out an angle, I can use trig inverse. Inverse just means we're going to go backwards. So if you're missing an angle, which we are, x is in an angle, it's on the inside, then we can use trig inverse. And the calculator, if you look on your calculator, trig inverse, there are keys for it. So it's like this. It's like sine inverse, cosine inverse, tangent inverse. But your calculators have to be in a very special mode. You have to go to mode, change it to degree, and then you have to be careful because it sometimes resets. So we're just going to use our trig chart, and we're going to go backwards on our trig chart. So here's how this is going to work. If I know that the cosine ratio is 0.9945, then my angle has to be 6 degrees. If I know that the tangent ratio is 1.4826, then my angle has to be 56 degrees. So I'm going to go back to this problem and I'm pretty much going to work backwards. So I'm going to pretend like it's a normal trig problem. So I'm going to go ahead and circle my angle. I'm going to label my sides. So 5 would be opposite and 14 would be the hypotenuse. So this would be a sine problem. Opposite hypotenuse, that'd be sine. So sine of x equals opposite 5 over 14. Well, now I'm going to go to the calculator and I'm going to find out what is 5 over 14. I don't know sine of x. I don't know that, so I'm going to do 5 over 14. And I'm going to write that 4 places out. So that would be 0.3571. Because now I'm going to go to my chart and I'm going to go backwards. That's what sine inverse is. So to find x, I'm going to take the sine inverse of 0.3571, which means I'm going to go back to my chart and I'm going to look in the sine column for what's closest to 0.3571. Now, you're probably not going to find it exactly. So if I'm in the sine column and I'm looking for 0.3571, well, I have 0.3420, 0.3584, 0.3746. And we're just going to ask ourselves, what's closest to 0.3571? Well, that would be 0.3584, which is 21 degrees. So what's the value of x in this problem? Well, x is about 21 degrees. That's it. So if you can go forwards, now we're just going backwards. Let's take a look at another one. So I'm missing x. It's still an angle. So I'm going to go ahead and circle and pretend like this is a trig problem. So I'm going to circle that acute angle. I'm going to label my sides. I know that 18 is across, which would make that opposite. I know that 59 is adjacent. I don't have the hypotenuse. Doesn't matter. I'm not trying to find it. I just need this angle. So opposite and adjacent would be tangent. So tangent of x equals opposite is 18 over 59. And now I'm going to see what that decimal is. So 18 over 59, and I'm going to write it out 4 places, is 0.305, and it says 08. So it would be 0.3051. And now I'm going to find out what's tangent inverse, that's what that -1 means, of 0.3051. So this is where I need to be careful, because now I'm going to go back to the chart. Now I'm looking for the decimal now. And I'm looking in the tangent column for 0.3051. So see if you can find something that's close to 0.3051 in your tangent column. Well, 0.3051 is pretty close to 0.3057, which would be about 17 degrees. So back to that problem, x would be about or approximately 17 degrees. I'm still using this symbol because I am rounding. This wasn't exactly on my chart. There was something close to it at 17. So I'm going to say it's approximately 17 degrees. So taking a look at another one, x is still in the angle. So if x is on the outside and you have an angle, then that'd just be normal trig. But if they give you the legs or the sides and x is on the inside, that would be trig inverse going backwards. So I'm going to go ahead and circle that angle. Okay, if I go across opposite, there's nothing there. So I'm not going to need opposite. Across from the box is my hypotenuse. So there's my hypotenuse. And then 58 would be adjacent. So asking yourself, which one uses adjacent and hypotenuse? Well, that would be cosine. So cosine of x, because I don't know my angle, would be adjacent 58 over 75. And then I'm going to give you a minute to see if you can figure out this problem from here. Convert it to a decimal. Go look at your chart and see if you can figure it out. Well, 58 over 75 is 0.773 repeating, so we're just going to say cut it off, 0.7733. So now to get x, I need to find cosine inverse with the -1 of 0.7733. And this is what it would look like in your calculator if we changed the radian mode to degree mode. We just have to remember to constantly do that. And if you go look over at your chart, remember, you're not going to find 0.7733 in your chart, but if you're doing cosine and you're in the right spot, you're going to see 0.7771, right about 39 degrees. So that would make x approximately 39 degrees. And that's it. Now, people always wonder, why can't we just subtract from 180, right? We've seen triangles before, and if that's 30 and that's 50, then I just add and subtract from 180. But I need 2 angles to do that, which I don't have. I only know that it's a right triangle, and then they gave me the sides, but they didn't give me enough information about the angles to subtract. So that's whenever we work backwards, trig inverse. We'll pick up in the next video. We'll take a look at a few more of these problems and go through some of these word problems together. Make